Ryan, how you doing? Ryan, how you doing?
Pretty good.
Good, I can hear you. Chris, how you doing?
Not bad, you?
Pretty good. Elias, who else? Matt, can you hear me?
Yes, sir.
Good, okay. How about you, Elias, can you hear me?
Yes, sir.
All right, I'm gonna just take roll real quick while y'all are checking in. How's everybody doing?
Pretty good.
Good.
How are your classes in the morning?
I've only had one so far. I don't
I
have no
only had
idea.
one, so.
Okay. Chris. See who else is out there. Chris, did you ever get out fishing?
Oh, yeah.
Okay, good. Oh, Hector's here. Hector, how you doing?
I'm fine. How are you?
Good, I can hear you. Good, who else just hopped on? Looks like, let me change my view. Ah, John, can you hear me?
Yes, sir.
Good. How about you, Terrence? Can you hear me?
Yes.
Very
Well,
good.
That's just the most enthusiastic thing you've heard all day.
DJ, how you doing?
Good.
You can hear me okay?
Yes.
Okay, good.
Ah,
Okay, so for those in the shower or anywhere else that aren't here, they will be able to view this, or you will be able to go back. And if you don't have enough time during class, because some of this information I'll go over fairly quickly, you can call it back up again and stop at a certain frame if you want to finish taking your notes, or look at an example more in depth. Okay, so feel free to call this up. And I'm going to admit Charles. Charles, can you hear me?
I can.
All right, good. Welcome aboard. Well, now I think all we're missing is Sam and David and Ben. All right.
Dan's at the school.
Okay, so this class is being recorded, so feel free to refer back to it if need be. I may mute you at sometimes during the presentation just so I can focus on my presentation, and then I can unmute you all for questions. So if I do that, please don't take any offense to it. Just doing it so we can get through example problems quickly. Everybody should have a calculator now that can do sine, cosine, and tangent. Hector, what you got?
Sir, I just went to the link for your YouTube channel. It says that you have no content.
That's because the first content that's going to be posted is this class.
Matt.
Okay, I will post this class later today.
What
upload.
about your other videos? Will you post those again, or are those?
They weren't on there?
No, your other videos were not on there.
Okay, I need to
It's
check
because
that.
it's because you didn't list them. I think it's because they were unlisted.
Okay, so I need to list my other videos. I will put my other videos on there because you might want to go back and look at some of those as well. Good
Yes.
point. All right. Thanks, Hector. Appreciate it.
No problem.
All right. The homework for tonight is on Blackbaud. It's in class announcements. Blackbaud is still down, so if you're not able to get that later on today, I'll go ahead and email it out to everybody. But we will have homework grades. The main thing on homework is to show all work, especially in this part where we're doing trig. I have to see your setup to give you credit for the problem. You just can't put the answer down. So that's real important. Calculators, anybody have a problem with calculators? Everybody good on calculators?
I need to buy a new one because I lost mine.
How do you use like
Okay.
tan and
In the
cosine?
interim, you should be able to take sine, cosine, and tangent on your cell phone. It's a lot easier on a calculator because you can do the whole complete operation, but as a Band-Aid, you can always take it on your phone and write the number down and then finish the problem.
Well, what do you use like
You
the
will
tan
have
and cosine for?
Participation grades. Nick, let me see your face. Put your hood down. There you go. Thank you. There you go. All right. We will have participation grades just like you have in all the other marking periods. Everybody's participating right now that's online. You don't have to be online to participate. If you're viewing the class in the recorded version, I'll be able to tell by turning in your homework and asking questions or hopping on my office hours with a question to see if you are participating.
Sir, one more question.
Before we get started, does anybody have any quick questions of a general nature?
How do you use like the tan and cosine and stuff? Like
How do you use what?
the tan and cosine and stuff.
We're going to talk about that today.
Oh, okay.
Okay, so hopefully that question will be answered by the time we finish today's class. All right. All right, I'm gonna.
Hector, why do you have palm trees behind you?
You can change your background.
Okay, so
Really
we're gonna
felt
go ahead and get
fantastic,
started.
bro.
I'm gonna mute everybody just so I can see what I'm doing in regard to instruction.
Uh-oh.
Oh,
Sir,
All right. Everybody see the blackboard okay?
yes.
No, sir.
Or
You need
whiteboard?
You need to have your as the main screen.
What's that?
You need to have your screen as the main
you
screen.
can pin his video.
But you can see it, right?
Yeah, you pin his
Pin
video.
him. Hector, you can pin him.
All right. So the objective today is exactly what Nick asked, be able to solve right triangles using trig. Trig is sine, cosine, tangent. Right. For homework, your homework is a handout that's in Blackboard. It's real important to show work, and I don't need you to put it in the Dropbox till Wednesday, right before our next class. All right, so you have a couple of days to work through it. Additionally, though, I put a review page out of the workbook, page 103. Before you try this homework, look at page 103 in your workbook. Make sure all these problems make sense. That will make your homework a whole lot easier. And in Blackboard now is the solution to page 103. You have the solutions to this already posted in Blackboard. So make sure you do this first because it'll save you a whole lot of time doing your homework, all right? It'll lay out that you understand how to set up the trig functions, all right? You will notice that your daily quiz grades are not in Blackboard yet. That's because Blackboard went down before I had a chance to grade them all. I will put it in there. The grade for everybody is optional. If you don't like the grade that's in there, just let me know, email me, and I will take it out. So if you didn't do the daily quiz for some reason or couldn't get it to me and there's a 0 in there, just shoot me an email and I'll take the 0 out. All right, I do have office hours starting today from 2 to 2:30. I will be on Zoom. You can hop on my Zoom meeting, and if you have any questions about today's class, let me know Friday from 9 to 9:50. Those are standing office hours. They should be in effect for a while.
Wait,
All
so
right?
do we have is that going to be the way it works for every daily quiz where we just, if we like the grade, then we keep it, or what?
Not every daily quiz. We spun for this one. We'll
okay.
continue to try to spin. The only problem is I'll have to do the spinning. We won't have you guys spin. So wish me luck. All right, now we're going to switch over here. I got to figure out how to get my camera view. Well, all right. First example is this one. Everybody see that?
Sure.
Sir. Yes.
Is it okay? All right.
Yes.
From a previous homework from last week, there was a problem like this. It was number 13 on the homework from the 27th. It was the last homework that you turned in. This problem was a little difficult, so let's go over it.
What homework was that again?
This was the problem where you knew that DB was 4. Notice this is a 30, 60, 90 triangle. This is a 30, 60, 90 triangle. And you were asked to find AD. Well, first, just look at this triangle. In just this triangle, if this is the short side, what side is this?
That would be the like the height of it, right?
That would be, well, if all you were doing was looking at this triangle,
Oh, that'd be the
the hypotenuse, what do we call this?
The long side.
The
Yeah.
long leg. How many times bigger is the long leg than the short leg?
2 times.
2.
Nope, the hypotenuse is 2 times.
Radical 3.
Right. So I know that CD is 4 radical 3. Okay, so this distance right here, I know is 4 radical 3. But now, just look at this triangle. Is this triangle over here, don't look at this one. Is this triangle also a 30, 60, 90?
Yes.
Yeah.
Yes.
And this is again, what? The short, long, or hypotenuse?
The short.
Short.
It's the what?
Short.
Short.
Short. So if this is the short side, how do I get this one? What's this one called?
The long leg.
Long, because here's my 90-degree angle, here's my hypotenuse. So that's the long leg. So
What if-
what do I do to the short leg to get the long leg?
Multiply it by radical
By
3.
the square root.
Multiply it by the square root of 3. Square root of 3 times the square root of 3 is 3. 3 times 4 is 12. 12 is my answer. Okay? Here's the answers to the rest of the problems in the daily quiz. Okay. Everybody has credit for number 3. Okay? Because the answer to number 3 is that there is no answer. All right? Because what do we know about this problem in number 3? We know it's a right triangle, and we know the hypotenuse is 16. Well, there's different ways to draw a hypotenuse of 16 for one triangle. Okay, I meant to say that it had to be isosceles. I forgot to put that word in there, so that made the problem not doable. So the answer to that one is no answer, but that was a little tricky for this part since we're just introducing right triangles. So everybody received full credit for problem number 3. But does everybody understand why there is no answer?
Yes.
Okay. Let's review the tools we have for geometry right now. All right. How about, can everybody see this part right here?
Not really.
Is it in my screenshot?
It's
Yeah,
in your
blurry.
screenshot. It's just I can't really see it that well.
Okay, well, I'll go through it.
You got some glare going on.
Oh, we got some glare?
I already pinned it. It's just that the I can slightly see it. It's the 30, 60, 90. It's a little dim.
It's blurry.
Yeah.
Hold on, the green. Okay. All right, well, maybe I'll just have to go all black in the future with my colors. Let me try to come closer. In fact, how do I get my screen to show?
I just did pin video.
There's like pin in the top left hand corner.
Coach Foley.
Spotlight video? There we go.
In the
Okay.
left hand corner.
All right, there. Is that better, Hector? Thank you.
Yes.
It is, yes. It's a
Yes.
lot
All
better.
right, let's review the tools that we have to solve right triangles. Remember, all these tools only apply to a triangle that has a 90-degree angle. First, we talked about the Pythagorean theorem. We can use the Pythagorean theorem when we have 2 sides known, and we can solve for the third side, because we know a squared plus b squared is c squared. Okay, so that works when we know 2 sides and want to get the third side. We just talked about the 45, 45, 90, and the 30, 60, 90. These are very special cases. Notice if it's a 45, 45, 90, I know all the angles. If I know one side, I can get the other two sides. If it meets the criteria to be a 30, 60, 90, if I know one side, I can get the other two sides. And notice, if I know all the angles and all three sides, I have solved the triangle. Remember, solving a triangle means finding all the angles and all the sides. And now we're going to talk about trig. Trig, for those of you that work a lot with tools, is like vice grips. Okay? You can do a lot of things with vice grips. It can be a vise, it can be a wrench, it can be pliers. Okay? If you really know how to do this, use this trig tool well, you don't need to know any of these other ones. All the problems that you can solve in this chapter, you can use this one tool. Okay? So this is a very powerful tool. If you know one side and one angle, you can solve the triangle. You can find the other two sides and the other two angles. If you know two sides, you can find the other side and all the angles. That's pretty powerful. This knowing two sides and solving the triangle is tomorrow's class. Today, we're really going to focus on this one right here. If you know a side and one other angle, other than the 90 degree, you can solve the whole triangle, okay? And in the trig toolkit, there's really three separate tools: sine, cosine, and tangent. And that's really what I want to make sure you understand how to use today, are those three tools of trigonometry, all right? So this is something you might want to go back and write down. That's why I wanted to get close enough for you to see it really well, all right? So let's see how we can use this with an example. Okay, last time we introduced SOHCAHTOA. This is just an acronym to explain what sine, cosine, and tangent are. Sine, cosine, and tangent are ratios. Okay? Sine is the ratio of the opposite side to the hypotenuse. Cosine, adjacent side to the hypotenuse, and tangent, opposite to adjacent. So if I have a problem like this, and I wanted to try to solve it, well, the first thing I might notice is if this is 30, what's this angle? What would that angle have to be?
60.
60.
This is a 30, 60, 90 triangle. So I can use my 30, 60, 90 tool. All right. If 10 is the short leg, what's the long leg going to be?
10 square root of 3.
10 square root of 3. That was pretty easy. That's the answer. That's what X is. Okay. But let's see how we can solve it using the trig tool. All right. One of the most important things you have to figure out using trig is, what is your reference point going to be? In this problem, I'm going to use the 30-degree angle as the reference point. So just imagine that you're standing right there. Okay? If you're standing there, what is it that you're trying to find? The opposite or the adjacent side?
The adjacent.
The adjacent. What is it that you know? The
Opposite side.
opposite. So I know the opposite and I'm trying to find the adjacent. So which one of these talks about opposite and adjacent?
Tangent.
Tangent. So I'm going to use the tangent tool. Okay. I can say that the tangent of 30 degrees, because I'm standing here, the tangent of 30 degrees is equal to what? The opposite side over the adjacent. Does everybody see that?
Yep.
All right. How am I going to solve this? My X is down here. Well, this is a proportion, isn't it? This is like tangent of 30 over 1. How would you solve this proportion?
Cross multiply.
So you would say X tangent of 30 equals 1 times 10, which is 10. Okay, remember, tangent of 30 is a number. Okay, we can't break that up. It stays tangent of 30. If you want to put it in your calculator and find out what number it is, you can put it in place of it. But I would recommend you leave it tangent of 30 until the very end of the problem. It'll make it easier to solve. Because if I want to get X by itself, how do I get rid of tangent 30?
Divide by
How do we
3.
get rid of anything that we want to isolate X by itself?
Divide
How
by
do I get rid
X.
of this? If this was 2 times X, how would I get rid of the 2?
Divide by 2.
Divide by 2. Okay.
Oh, divide by tangent of 30. Right.
What's that?
Divide by tangent of 30.
Right. You would divide by tangent of 30. Did somebody just join us?
Didn't?
You can.
Okay. So I would divide by the tangent of 30. Both sides. So that cancels. So now x is just equal to, now in your calculator, you can just go 10 divided by, hit the tan button, hit 30, and you'll get an answer. Who got an answer?
10 square root
Divided
of
by
3.
tangent of 30.
10 square root of 3.
Okay, 10 square root of 3. Good.
I
Did
got-
anybody get a decimal answer?
Yes, I did.
What'd you get?
I got 56.712818. Where's 56?
Okay, we'll talk about that one in a minute. Who got another answer?
I got 1/3.
1/3, nope, 10 divided by tangent of 30.
I got negative 1.56.
Can't be a negative number. Anybody else get a different answer?
Wait,
Negative
sure,
10 divided by tangent of 30.
sure. I did it again and I got 0.33333 going on forever.
I got
That's what I got.
No?
I got negative
Anybody else?
4.
17.3 something.
Ah.
Yeah, I got 17.32 something as well.
That is the correct answer, 17.32. There's several reasons why some of you might be getting answers other than 17.32. Okay, you have to make sure your calculator is in the radian mode. Okay, a lot of your calculators will have a button that says mode. If you hit that, most likely you will either be, I'm sorry, you do not want to be in radian. You want to make sure that you're in degree mode. Okay, so you want to make sure that you're in the degree mode. If you're in radian mode, make sure that you change it to the degree mode.
How do you do that?
I'm in it.
You just highlight it. Hit mode, and when you can see you have a choice between degrees and radian, highlight degrees and hit enter.
I don't see a mode on mine. Like, hold on, let me just show mine to see if it
At
picks
the
up.
end of class, for those that aren't able to get that, if we have some time at the end of class, I can work with you individually. Might even be able to just share your screen real quick with me, and we'll figure it out that way. Let's do a quick check, though. If your calculator is in the degree mode, what do you get for the tangent of 30?
17.32. Didn't we just do that? Oh no, we were finding x. That's my fault. No.
Just the tangent of 30.
0.57.
But DJ.
0.577. Okay. Generally, if you write this out, you want to write it to the nearest hundredth, and that way you can round your answer off accurately. Write it down to the nearest thousandth, and that way you can round your answer off accurately to the nearest hundredth. Okay, so tangent of 30 is 0.577. Let's try another one. Sine of 48. What do you get the sine of 48 to be?
0.743.
0.743. All right, good. Finally, sine of 57.
57. 0.44. 5.44. Or 0.544.
Right, 0.543. Okay. Notice sine, cosine, and tangent always look like they're less than 1. Does that make sense?
Yes.
Yes.
Yeah. Because what is sine? What are they? Sine was this side divided by the hypotenuse. The hypotenuse always has to be bigger than this side, doesn't it? So it's going to be less than 1. Now, the only one that can be bigger than 1 is tangent. Because if this was the long leg and this was the short leg, now my tangent would be greater than 1. So tangent can be greater than 1. Let's look at the two answers we got for this problem. Using tangent, I got 17.32 as the answer. Using 30, 60, 90 logic, I got 10 radical 3. Why did I get two different answers?
They're the same.
They're the same, that's right. If you go 10 times the square root of 3 in your calculator, you will get 17.32. Okay. So in this section, we will often express answers as radicals or decimals. If it's a multiple choice question and all the answers are in radicals, and you do the problem this way and get a decimal, well, it's real easy to see which one is the correct answer. Just put all these in your calculator till you get this answer. Does that make sense?
Yep.
Okay, all right, good. So you may be asking yourself, well, this was really easy to do. This was a lot of work. Why do we have to know this? Because this only works for this special type triangle. What if instead of a 30, 60, 90, it was a 20, 70, 90? It wouldn't work. This would not work, would it? This always works. Okay, this will always work. So now let's try an example where it's not a 30, 60, 90 triangle. So I'm just going to roll over. Okay, can everybody see this example?
Yes, sir.
Yes,
Okay.
sir.
You see it okay, Hector?
Yes.
Notice I want to solve this triangle. I know the hypotenuse is 18. I know this angle's 37, and it is a right triangle. Make sure you always check to make sure it's a right triangle, because if it's not a right triangle, can you use these tools?
No.
No. It is a right triangle, so I want to solve the triangle. I want to find the other angle and the other two sides. Well, the other angle is pretty easy to find. How would I find Z? Any thoughts on how I'd find Z? What do you think?
I don't know.
This is 90. This is 37. What's this?
53.
53. Because if this is 90, these two angles have to be the other 90 degrees. So I can just go 90 minus 37 is 53. So now I know this is 53. Does that make sense? So now
Yes,
I
sir.
found all three angles. Okay. Now I want to find my sides. Okay. Which one do you want to find first, X or Y?
X.
Okay. If I want to find X, notice, well, where do you want to stand? At A or B?
A.
Okay. If you want to stand at A, okay, I'm going to stand here. All right. So this is my adjacent side. This is my opposite. And the hypotenuse is always the hypotenuse. It's always across from the 90-degree angle. So I know the hypotenuse, and I'm trying to find my adjacent. Who remembers what trig function relates adjacent and hypotenuse?
Cosine?
Cosine, right. All right, cosine does. So I can say that the
Cosine.
cosine of where I'm standing, 37, okay, and remember, that's a number. You can put this in your calculator and get a number for that, can't you? Cosine of 37 is equal to
0.798.
over the hypotenuse. X. There's the yeah. And in your homework, you have to write this down to get credit for the problem. You can't just put the answer. Okay, I need to see this written down, because that tells me you understand that cosine is the right tool to use. You're standing here, so it's X over 18. The rest of it now is just being able to solve the algebraic problem. What would you do next to solve this problem?
Plug it in.
Yeah.
What do you mean by plug? Well, how do you plug it in?
Cross multiply.
Press
I can
cos
cross multiply.
37.
Put this
You have
over
to put
1,
that over 1.
and I get 18 cosine of 37. Notice I wrote it as 18 cosine of 37. I would not recommend that you write it as cosine of 37 times 18. And then a lot of times you may think you can take the cosine of this product. That is not true. This is one whole complete number. You want to take this number and multiply it by 18. So I like to write it this way, because now I know that the only thing I'm taking the cosine of is this angle, 37 degrees, and I'm multiplying it by 18, and that's going to equal what?
14.38.
0.338 if you round it off.
14.38.
Yes, sir.
All right, and I'm going to look at this and make sure it makes sense. Does it make sense that this is 14 if this is 18? Yeah, that makes sense, doesn't it? I'm sorry, this. Does it make sense that this is 14.38 if this is 18?
Yes.
Yeah, that makes sense. So now I have X. Okay, there's now a couple of ways that you can find Y. Who can tell me one way?
Dividing 14.38 by radical 3.
Oh, you can put in the
See, I
8
can't do
squared plus
that.
b.
Wait, no.
because
It's not.
You're
It's not
using
30.
the 60-90 tool, and this
Yep.
is not a 30-degree angle.
You do a
That's
squared
the
plus
wrong
b
tool.
squared
You
equals
see
c
that?
squared.
Yep.
Could you do
You can
tangent?
only use the 30-60-90 tool on 30-60-90 triangles. This is not a 30-60-90 triangle. So I have to use a tool that is allowed on this type triangle.
Could
Any
you
other thoughts?
Pythagorean?
Pythagorean theorem. Is it a squared plus b squared c squared?
Yes.
So you could find y that way. Who can think of a way where I can find y using my trig tool? What do you think, Hector?
Tangent?
Tangent.
Tangent, okay. Good. Let me change my view here so I can see everybody. That's better. All right. So if I wanted to use my tangent tool, I'm standing here. So Hector, what do I write? Tangent of what?
So you do tangent of 53.
Okay, I could do tangent of 53. So I'm no longer standing here. If you want to do tangent of 53, this is now my reference point, right?
Yes.
Or tangent of 90, right?
So now I can say the tangent of 53. Well, what is the tangent? Tangent is opposite over adjacent, right?
Mm-hmm.
And that's on your theorem sheet. SOHCAHTOA is on your theorem sheet, so you don't have to memorize that. Tangent is opposite over adjacent. If I'm standing here, what side is opposite me?
14.38.
14.38, good. And what side is adjacent to me?
Y.
Y. Okay. So now this is like tangent of 53 over 1. When I cross multiply, what do I get?
Y times tangent of 53 equals 14.38.
Okay, so what would you do next?
So you want to find the tangent first.
Well, you could take the tangent of 53 right now and put that number in.
Is y the
I would
tangent?
recommend that you wait, okay, to get rid of round off error. So I would go ahead and divide by tangent of 53 next
Oh,
and cancel that out and divide by tangent. You know, let the calculator do all the hard work for you, okay? Because now you're just left with y over here. All you have to put is 14.38 divided by tangent of 53, and you have the answer.
10.84.
Tell me what you get.
10.84.
Okay?
That's rounded up.
10.8. I got like 10.83 and
Who agrees
10.84.
with that? 10.84?
Yeah, if it's
Yeah.
rounded.
Somebody
Yep.
else gets 10.84?
Mhm.
Okay.
So is the variable y usually always the tangent?
No, it's not. Whether it's sine, cosine, or tangent has nothing to do with x and y. It has to do with where you're standing. It's
Oh, so-
where you're standing, you have to find the opposite side, which could be x or y, and the adjacent side. That's what determines whether you use sine, cosine.
Oh, so the adjacent side is tangent and the opposite side is sine.
Well, in this problem right here, before we knew what x was, okay, I knew the hypotenuse and I was trying to find this side.
Mhm.
If I was standing here, that was the adjacent and the hypotenuse, right?
Mhm.
So you have to look at SOHCAHTOA and say, what trig function, let's come back over here. What trig function talks about adjacent and hypotenuse? Cosine.
Cosine.
That's how you find out what tool to use. Does that make sense?
Uh-huh.
Okay, all right, good. Let's do an exercise though real quick on what Ryan just asked about to make sure that we understand what tool to use. All right, let's look at this problem since we have it filled out now. Let's say I want the sine of 53. What's the sine of 53 going to equal? Right. What do you think? Sine of 53. I'm here. Sine is what?
0.798.
0.798.
Let's just write it as a ratio. All I wanted is a ratio. Sine of 53 is, write it as a ratio. Fill in the blanks. Is what over what?
53 over
18
14.
over.
Sine of 53. If I'm taking the sine of 53, do you agree I'm at this angle?
Yes.
I'm at this angle. How did I define sine? Opposite over hypotenuse, right?
So opposite
What
over
side is opposite from where I'm standing?
side
The
AC.
long side. The
Which is
long
what?
side.
14.38.
14.38. What's in the bottom?
53.
Hypotenuse, which is what?
18.
18. Okay, now do me a favor. Take 14.38 and divide it by 18. What do you get?
0.79.
0.798 repeating.
0.79. All right, now do me a favor. Now take sine of 53 in your calculator. Sine of 53 is what?
0.798. 0.798.
You see that?
Mhm.
So hopefully that shows you how it all comes together. Okay, so let's try another one. What if I gave you cosine
Yeah, Chris.
of 37? Fill in the blanks. John, what would you put up top? Cosine of 37.
That one on the right. I can't really see it.
What's that? Using
Wouldn't
this
it be
drawing. What side goes up here on top for cosine?
the opposite?
Cosine. What is cosine? Look at Sakatoa. Cosine is what?
Adjacent.
Adjacent over hypotenuse, right?
Yeah.
Okay, so I'm no
So it'd be-
longer standing here. I'm at the 37. I'm standing here.
So it would be
So what side is
14.38.
my adjacent side?
14.348.
14.38. What's my hypotenuse?
18.
18. Oh, well, that's the same. That's going to be equal to 0.79. In your calculator, take the cosine of 37. What do you get? Cosine of 37.
0.999.
0.79.
0.798.
You got the same thing as you got up here, right?
Yeah.
If you think about that, that makes sense. Because if you're standing up here at the 53, sine is opposite over hypotenuse. Opposite over hypotenuse. Now, if you get up and move over to here and take the cosine, cosine is adjacent over hypotenuse. It's the same sides, isn't it? Notice when you move from here over to here, your opposite and adjacent sides switch. So what will always be true is the sine of one angle will be the same as the cosine of its complement. Who remembers what we mean by complementary angles? Complementary angles are angles that do what? Add up to 90. So the sine of one angle will always be the same as the cosine of its complement, the angle that if you subtract this one from 90. And sure enough, we got them to be the same. Okay? All right. All right. Let's do one more. Let's do a couple more because I think this is a good exercise. Work through. What if I wanted to find the tangent of A? Tangent of A. Well, where is A?
A is,
A is the 37 degrees.
yeah. Hmm.
See, sometimes you will see this as an angle and sometimes you'll see it as a point. It's nothing more than two different ways of telling you stand here. Does that make sense? Okay. So if I'm standing at A, tangent is what? What's tangent, Chris?
BC or 10.8. Oh, never mind.
No, in terms of sides. Tangent is defined as what? What over what? What did we define tangent as?
Bricks.
It's like something over X.
No, let's
Or
come back over here.
Opposite over adjacent?
Tangent is what?
That's the
Opposite over adjacent.
hypotenuse or
Opposite
something.
over adjacent, okay?
Oh,
Tangent is opposite over adjacent. So if I'm standing here, what's my opposite side?
BC,
Is
BC.
what?
10.84.
10.84. And it's over what? The
Over
adjacent, which is what?
14.38.
14.38.
Put that in your calculator. What's 10.84 divided by 14.38?
0.7538. Blah, blah, blah.
0.75. Okay. Now, we know that A is really 37 degrees. So if I take the tangent of 37 degrees, shouldn't I get this number? Let's see if you do. Take the tangent of 37.
Yeah, it's 0.75.
Okay. See, that's how your calculator knows what to put in there for tangent of 37. It's 0.75 because all triangles that are 37, 53, 90 are all similar, aren't they? And
Yes,
if they're
sir.
all similar, the ratio of the opposite to the adjacent is always going to be the same. So you see, sine, cosine, and tangent are all based on the fact that these triangles, 37, 53, 90s, are all similar. Does that make sense?
Do you
Yes,
always
sir.
have to know at least one side, or
If
no?
you're going to use sine, cosine, and tangent, you need to one, make sure you have a 90-degree angle, and then you need to know one angle and one side. If you know one angle and one side, you can always find the rest of the angles and sides.
All right.
If
All
you
right.
use this angle and this side, this angle and this side.
All right.
Depending on what you know, really determines if you're going to use sine, cosine, or tangent. Does that make sense?
All right.
Yes.
Yeah, sounds good.
Okay, all right. We're almost out of time. Let's do one more example. Suppose I gave you this problem. It's a triangle. This side is 8, and my angles are 50, 60, and 70.
Alyssa, you can play it.
X. How would you find X?
To me, so I can stop my video.
DJ.
What do you think? How would I find X?
You could use any of them, right? Or wait, no.
How would I find X? Any ideas?
That's very.
Any ideas on how you can find X?
Not really.
Yeah, the reason is because we don't know how to do that problem. Why?
Because it's not a right triangle.
Because it's not a right triangle. Okay, by next week, we're going to figure out how to solve this even though there's not a 90-degree angle in there. But remember, all the tools we talked about today, remember all these tools that we talked about today. What was common about all those tools? They were all for right triangles. The triangle had to have a 90-degree angle. To use the Pythagorean theorem, you need a 90-degree angle. 90-degree angle, 90-degree angle. To use sine, cosine, and tangent, you have to have a 90-degree angle, right? Okay. Last thing I want to make sure that you understand is let's come back over to this problem. Okay, all right. On this problem, what if I asked you to find the tangent of C? What over what? Okay. How do we define the tangent? What do you think?
Opposite over adjacent.
Define tangent. Opposite over adjacent.
Adjacent.
Can I find tangent of C?
No.
That's hard
Yes.
to do, isn't it?
18.
That's adjacent side, so no.
Well, the problem is, I don't know if you're standing here, these are both adjacent. aren't
Yeah.
they? So which one? I don't know which one to pick. Okay.
Can you pick either of them?
No, you can pick neither of them. Remember, we said that in this type problem, you can stand here and define sine, cosine, and tangent. You can stand here and define sine, cosine, and tangent. But you can never stand at the 90-degree angle. Because if you're standing at the 90-degree angle, we're back all the way to this problem we had in the beginning of class. Remember this one right here? Where if all we knew was the 90 degrees, we don't know if that 16 length hypotenuse goes like this or this. We have to know another angle. So you never stand at the 90-degree angle. Okay? So you're either taking the tangent standing here or standing here. You can never stand at the 90-degree angle. Does that make sense?
Yes, sir.
Okay. All right, good. So let's just recap real quick. Okay, so your homework is a handout. Okay, I want you to do the handout just like we did that last example. You have to show me the trig ratio that you're using. Okay, and for a lot of them, you can use different ones, several. You have to show your setup and then show me your answer, and you'll turn that into Blackboard before the next class, which will not be until Wednesday at 12 o'clock.
When is Blackboard going to be back up?
I don't know. I'm going to go check after this class. If it's not back up by tomorrow, and you're not able to get into the class announcements to open up the homework, I will go ahead and email it out to everybody.
Busman sent out an email saying that they've been talking with Blackbot and that they have no guess of when it's back yet. Blackbot doesn't know when it's coming back.
Yeah, it's like a server-wide Blackboard issue. It's not like
Okay.
Benedictine
I will
itself.
go ahead and email this homework out to you this afternoon then. Okay?
All right.
That was the solution to page 103. So make sure you look at page 103 in the solution first before you try these problems. It'll make it a whole lot easier if you take the time to make sure you understand page 103.
And is that due tomorrow or Wednesday?
Wednesday.
All right.
Wednesday
All right.
before our next class, which is at noon. Okay?
So, just look at workbook page 103 and the solution in Blackboard that's going to be emailed to us, and then do the handout.
And this handout, only the handout do you have to put in Blackboard. Page
Can you go back to
103,
the,
I just make sure you understand before you do the handout. It'll help you out a lot.
Can you go back to the theorem thing?
What's that?
Can you go back to the theorem thing? On the board where the theorems are?
You mean the tools?
Yeah.
Okay, all the tools are on your theorem sheet, or if you want to replay this and copy it down nice and neat, you'll have that to refer to for every quiz and test. Because remember, every quiz and test is going to be open note. So if that tool list helps you, I would go back and make sure you have a nice copy of that on a sheet of paper and just use it in place of your theorem sheet. Matt, question?
So in class announcements on Blackboard, there's a homework for March 30.
Goodness.
Right, that's the homework that I'm talking about right here. Because today is March 30th, so that is the homework sheet. If you are able to were you able to get to that and open it?
Yes.
Okay, that is the homework. So that's where you want to go to get your homework that's due Wednesday. Okay, is go into Blackboard and go to class announcements, and there's your homework. And the solution to page 103 is in that same document. Okay. So we're out of
Just the
time.
documents that aren't working.
We'll see y'all Wednesday again at noon. Does anybody have any calculator issues where they weren't able to find sine, cosine, and tangent numbers like we were over there? Hector?
Yes, I did. So will you, because like, I have it. I have sine, cosine, and tangent on it. I just can't figure out how to get to degree mode.
Okay. All right. Everybody else, unless you have a question, that's it for class. You can go ahead and log off. Have a great day.
All right. Thank you. You too.
You sure? Thanks, sir.
So Hector, I'm going to give you permission, maybe. Can you share your screen? Well, let's just talk through. What kind of calculator do you have?
A TI-35 Solar Galaxy.
Okay. Is there a mode button on it?
I don't see any. Hold on, let me just show you mine. There, that's
Okay. Move it. Let me see the other buttons. On the very far left, those red buttons, it looks like, what do they say?
all clear, and then it's AC, then CE/C.
Yeah, are there any buttons on it that say something like R to D or D to R, radians to degrees and degrees to radians?
No, all I see is like DRG or
DRG. Yes, that's the one I want because that's degrees, radians, and gradients. You want the DRG button to be D, not R. So go ahead and press it, and you should see D, R, and G on your screen. Stop pressing it when the D is displayed. Does that make sense?
okay, let me just show you. All right, so I pressed the DRG button once and it says RAD.
Right, that's radians. Push it again, and it
Then
says D gradients. Push it again. Okay, now what's it say?
nothing.
That's the one you want.
Let me, so
Now do this for me. Go ahead and take the sine of 30. Tell me what you get.
so just put 30 then sign.
No, you got to put sine and then 30. Sine 30, enter.
Okay, hold on a second. 30.
What's that?
That's what I got. 30.
Okay, when you normally put operations in your calculator, do you have to put the number in first?
Hold on, let me try that.
Go 30 sine.
Oh, 0.5.
There, now you're in degree mode, and that's the order of operations that you have to put in. You got to go 30 sine, enter, and you get 0.5. So if the problem was something like 5 times the sine of 30, you would have to go 30 sine, enter, times 5. Try
Okay,
that. 30 enter times 5. Did you get 2.5?
I got 0.1, but hold on. I think I might be doing something wrong. So 30 sine.
30 sine, enter, you should get 0.5.
I got 2.5.
Good. That's how you have to do it with that calculator.
All right, so
Okay. Is that an old calculator?
yes, it's an older one.
Yeah, you don't see many of those around anymore.
Yeah, it's an old one. It's from the 80s, I think.
Yeah. But it'll still work. You just have to make sure that and sometimes it's real easy to hit that button and get back into the radian or gradient mode. So if you ever see RAD or GRAD, make sure you get back in the degree mode where neither one of those is showing because the default is degrees.
So how do I do the so